So this is the pilot's end of the S70 Black Hawk. A couple of things that you wouldn't normally see. This is the ESSS control panel that controls those jugs outside. So normally this is not here, it's removed, and the poles and all the fittings that go with it are normally free. So the guys in the back can actually see forward, the loadmasters can actually see forward a whole lot better when that's gone. So they can help keep an eye on you. It's quite a spacious cockpit, particularly when you compare it to some of the other helicopters of its time. It's also a very strong cockpit. It's designed to be a survivable space for the guys in the front. Great big pieces of steel running up and down supporting the roof, and big box structures behind you keeping the hardware away from you. The seats are designed to stroke. You can see the rollers on the edge of the seat here on the rails, and there's a big energy absorbing system built into the seat. If you have a big impact and the seat strokes, the seat will end up down in the well that's down underneath here, hopefully absorbing most of the rate of descent, so that the guys in the front are a little bit more protected. The only real difficulty tends to be that you get what's known as a Black Hawk kiss, because your head typically strokes down and you pay some close attention to the cyclic stick here. Later versions of this aircraft had an airbag actually fitted to the cyclic, of all things, or they had a breakaway fitting that allowed the cyclic to break off it if you impacted it too hard. Other things, park brake here, that allowed you to position the aircraft on a slope without the wheels rolling off. It really was just a parking brake. The brakes on this aircraft don't stop you worth a damn. If you're doing a roll-on landing, it takes quite a long time to pull up. Other aircraft, and particularly the MRH or the Chinook, have much more effective power brakes than this aircraft does. Pretty standard instrument layout, instrument T here. A little more advanced with a couple more pointers and things like that from the Huey days. Pretty standard instrument layout for its day. VOR ADF were pretty standard. This aircraft was also fitted with a TACAN, mainly at the insistence of the Air Force, because in those days the TACAN was the major nav aid for the Air Force. They've since gone out of service just about everywhere. You can see in the middle here is the basic Doppler nav system, which is again very primitive nowadays, and has been replaced largely by the GPS systems. The AFCS control panel again is a more advanced control panel than the standard UH-60. It includes an auto hover capability and an auto approach to the hover capability, which was originally designed for the rescue aircraft in the US Army and US Air Force. This particular AFCS was originally designed for the Navy aircraft. We had it fitted to our aircraft instead, so much more capable AFCS in our aircraft than the standard UH-60. The other feature that this aircraft has that you didn't see anywhere else was the de-ice system. So we've got a blade de-ice system built in here that pulses heating elements in the blade and sheds ice off the blade. So this aircraft is quite capable of flight in icing, which is one thing that scared old Huey pilots to death. And I've been in icing in this aircraft many times, which is something Huey pilots can't say. Various bits and pieces that some people may have seen, a told card, takeoff and landing data card, which was typically filled out by the loadmasters in the back to let you know how much weight was on board the aircraft and what the aircraft was capable of lifting, the power that was available to the pilots in the current conditions, and we have one of those filled out for every takeoff and landing. Fairly impressive master caution panel down the centre here with lots of possibilities. About 20% of those are blank though, so they had the capability to put a few extras in. But again, lots of warning. Other things that are different, you see the standard round dial that the Huey pilots would have been accustomed to, and you can see the very early digital information being presented to the pilots. It's all colour-coded, so typically when it's in the green, you can have a quick look across and realise that everything's looking pretty good. When you start seeing yellow, that's a caution. When you start seeing red, you'd better do something about it. The vertical displays were originally designed, the concept was that you'd look across and see them all lined up when they were at their operating temperatures, everything would, but they never actually did. There's always a little bit of fluctuation in various things, but the green and the yellow worked pretty well. Reasonable visibility out the front. For a helicopter, a much larger instrument panel and coaming than other helicopters do, but you've got a lot more stuff to fit in. So, yeah, the visibility is very good directly out the front and down to your right, but across cockpit was quite poor. And this rather large overhead panel here got in your road as soon as there was any decent angle of bank set up. So if you're trying to look into a turn, you typically were looking into this large overhead panel, which is one reason why you see Black Hawks typically turning at less than 30 degrees or significantly more than 30 degrees, because at more than 30 degrees you can start seeing through your own overhead window rather than looking straight at the overhead console. So controls, a duplicated set of controls for both pilots. And obviously engine controls in the middle that you can both reach. It's a little bit muscle memory different if you're used to flying in the left seat to the right seat. The visibility pattern's a little bit different as well. You'll see that the panel's biased a little more over here. So typically I was always happier flying in the left-hand seat because I thought I could see a bit more from the left seat than I could from the right seat. And you know, if you look up, you can see multitude bits of circuit breakers and various bits and pieces. Some of the overhead cabin lighting structures set up here. But everything's very easily reachable, okay? Literally, even if you're sitting in the left-hand seat, you can reach over and start making selections on the right-hand seat if you need to, and vice versa. You can obviously, either pilot can reach every bit of it. The only thing that's a bit more difficult is the rotor brake, which is over here, structured on the right-hand side, and they've wired it shut so nobody's going to operate it. But even that, you can operate from the right-hand seat at a stretch. You reach over and slowly pull it on. This aeroplane, I was originally a Huey and Chinook pilot when I came to this aircraft. This aeroplane's much slicker. So it accelerates quite quickly, and in most cases, until you start filling the back up, the aeroplane has plenty of power, has a lot more surplus power than a Huey did, and even with people in the back. So that was a difficult thing to come through. The thing is, though, that this aeroplane presents you with much, much more information than something like the Huey or the early model Chinooks do. If you look at the later model Chinook cockpit, there's a very similar stuff. But for guys who'd come from the Huey, the Squirrel, there was much, much more information being presented to the pilot. Okay, and we used to say that it was a bit like trying to drink from the fire hose initially, yeah? There was so much coming at you that you had to select the things that you were going to pay attention to and the things that you were going to ignore. And it wasn't until people developed a bit more familiarity with the aircraft that they actually start paying attention to all of those inputs that are coming to the pilot. Now, for a modern helicopter pilot that's used to seeing those things from day one, I don't think it's so much of an issue, but you have to remember that the guys were coming to this aeroplane off a Huey, okay, and the old Huey had an NDB that worked half the time, and a really basic instrument layout that basically only allowed you to keep the aircraft right side up. Okay, this aeroplane has so much more and so much more information that it's trying to tell you about where you are, where you're going, what you're doing, and what other people are doing around you. And as I said, very big change in that information flow to the pilot compared to previous aircraft. And in fact, you know, when this aeroplane came into service, a lot of people said it's too complex. Okay, what we really need is we really need that truck, and we just need a truck to cart people around. And there's too much to learn. There's too much to figure out, and we want a really simple airplane. Yeah. So there was a lot of opposition. Opposition from some people about some of the complexities in this aircraft. I personally think that it allows us to do a whole bunch of things, and if you look at, you know, more modern aircraft, it allows you to do things and go places that you never would have been able to do or consider in previous aircraft types.